I'm now going to run through example 10 on the optimization booklet. So this is regarding the printer press. And you can read the information and say that the target is to produce 200,000 copies of a small catalogue, and we need to make sure that we do this most economically. So I read that as though we want to minimise the cost. So if we look at this example, we need to think about, well, what does the cost involve for running this printer press? So there are a couple of costs involved. Firstly, we've been told that it costs $8 per hour to run the printing press. So we've got to run the press, and that's $8 per hour. So we don't know how many hours we need to say H is hours. So that's 8H. And then the second cost involved with running the printing press is the number of plates. Each plate makes each impression, makes X catalogues, and there are lots of plates making that impression. So at $2 a plate, the cost for the plates are going to be 2 times X, because that's the number of plates. So our general cost is going to be C equals 8H plus the 2X. Problem is, we can't differentiate when we have two variables. So what we need to do is look at the information we've got and decipher that we need to know how many hours the printing press needs to work in order for us to calculate the cost. So we need to look at some of the information and calculate how many hours this printing press is going to work. So to work out the hours, we've got to understand how a printing press works. So what we have been told is that we need to produce 200,000 catalogues. Now, that's what we've got to work out is the time. Now, if we've got to produce 200,000 catalogues, and so the way the printer press works is that you've got a press, and when you press it down, it produces one catalogue. But it says it can produce 1,200 per hour. So essentially, with one plate on that impression, one plate, it will go print, 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 and there'll be 1,200 of those in an hour with just one plate. Now, if we had two plates, we would have print, 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 print. So we'd have 1,200 on this one and 1,200 on this one per hour. And again, 3 plates, you'd have 3 plates going. So the time it takes is 1,200 X, because X is the number of plates that we need. So our time is 200,000 divided by the 1,200 X. So we can now substitute that in to our equation. This could be simplified further, actually. Let's simplify that further. I wonder why that's blurred. Why is that blurred? I don't know why that was blurred. Apologies. So I was going to simplify that, but I'm going to put the 8 in there. So 8 lots of that divided by the 1,200 is 4,000 over 3x. I'm subbing that in, plus the 2x. And that just is simplified. Now, remember, the objective is to minimise the cost. So I want to differentiate the cost. So I need to find C dash of x. Wait for the focus to come back. It's really annoying because it's not focused for some reason. Why? There we go. Alright, so C dash of x. Now, that can be written as 4,000 over 3 to the, times x to the negative 1. So when I differentiate that, it becomes minus 4,000 over 3x to the negative 2. And then when we differentiate that, it just becomes 2 plus the 2. Obviously, rewriting that, you get minus 4,000 over 3x squared. Now I'm getting to the bottom of the screen, plus the 2. Alright, so let's think about what we need to do. We need to minimise the cost. So obviously we've got the derivative. We're going to set that equal to 0, and we're going to solve for x. So when we set that equal to 0, 0 there, I'm going to subtract the 2. Alternatively, I'm probably going to add that so it becomes positive actually. So I'll add that over that side. So let's write that down. I'm just going to clear the screen for a moment. I've now written that at the top. Let's do some multiplying. So we get 4,000 equals 6x squared. X squared equals 4,000 over 6. I'm going to square root that to give me x. Working that on the calculator, I get two answers, plus or minus. Let's be particular about that. And it becomes 25.82 or minus 25.82. Now, we can reject this answer, and we must say that, because we can't have a negative number of plates. So therefore we're looking at this. Now we need to verify that that produces the maximum. So we then take the second derivative. So if I take the second derivative, every time I move over here the board just goes out of focus, apologies. So if I take the second derivative, let's do that up here. We're looking at c dash dash of x. Now c dash of x was minus 4,000 over 3x plus the 2x. So let's differentiate that again. We get, well, it becomes 4,000. If the right's really small, the one's going to fail. 4,000, so over 3x squared with multiplied by 3x to 2. Plus, I'm having to read down here, obviously I need to times by the derivative, so I'm timesing by 3, plus 2x, because I have 2 then, and obviously that gives 2x. Alright, rewriting that nicely gives me 3 lots of 4, gives me 12,000 over 3x squared plus the 2x. Now I need to substitute 25.82 into the c dash dash of x, c double dash of c of 25.82. Sub that into there, calculate it, and work out whether we're dealing with a maximum or a minimum. So when I sub that in, I get 53.64, which is greater than 0. So when it's greater than 0, we say it's a local minimum. So c dash dash of 25.82 is greater than 0. So therefore we have a local minimum. And we can't have 25.82 plates, so therefore this would minimise the cost, this number of plates. So we say 26 plates to give us a round answer. Alright, now you're going to answer questions 1 to 10 in the optimisation booklet, and enjoy.